And then for part B is given as the equation of the circle is 2x squared plus 2y squared minus 8x minus 5y minus 1 equals 0. And the point of tangency is point C, which is 1 and -1. If you look at each equation of the circle, the coefficients of x squared and y squared are 2 and 2. But because we are going to get the center of the circle, it is important that we make the coefficients of x squared and y squared 1. Why? Because we are going to get the center of the circle. But if you are not going to get the center of the circle, it means you can use this equation the way you want. So let us divide all the terms by 2. Why? Simply to make the coefficients of x squared and y squared 1, so that we can get the correct values of the center of the circle. Even when we are looking for the radius, if we are looking for the radius, it is important also for you to make sure that the coefficients of x squared and y squared are 1. So dividing all the terms by 2, we shall have x squared plus y squared minus 4x, okay, minus 5 out of 2, y minus a half equals to 0. I've divided all the terms by 2. So this is the equation of the circle. So what do you do here? From here now you sketch your circle, then you assume your tangent is touching the circle at that point. Use a ruler, you can call it point B. And then the point C, they have said C, this is the point where the tangent, this is the tangent, the point where the tangent meets the circle. This is the point, they are calling point C, with coordinates 1 and -1. So we know that the center is in the middle here, and the radius is that line joining the center and the point in the circumference, making right angled with the tangent. So let us get the coordinates of the center. You have to compare this formula to the expanded equation of the circle, and you get the coordinates of the center are going to be 2 and 5 out of 4. If we compare coefficients and terms, these are going to be the coordinates of the center. After getting the coordinates of the center, now we need to find the gradient of the radius. So gradient of radius, and we know that radius is a line. So if you look here, this is the radius from the center to point C. Point C, let us change center and we just use A, because the point of tangency was given as C. So let's just say our center is A. Now from here, we can use the 2 points, which are the end points of the radius, to find the gradient of the radius. That is point A, which is the center, 2, 5 out of 4, and then the point of the circumference, that is point C, which is given as 1 and -1. We can use those 2 points, which are the end points of the radius, to find the gradient of the radius. You know that gradient of the line is given by chaining y, which is y2 minus y1, out of chaining x2 minus x1. So we come and name these points x1, y1, x2, y2. Then we substitute there. What is y2? -1 minus y1, 5 out of 4, divided by x2 is 1 minus 2. This here gives us, here's the calculator, -1 minus 5 divided by 4. I'm getting -9 out of 4, but we are dividing by 1 minus 2. I'm getting -1. If you divide by -1, we shall get negative 9 out of 4. Positive rather, because the negative and the negative will be positive here. Let me press the calculator. Negative 9 divided by 4 divided by negative 1. Yes, it is positive 9 out of 4. This is the gradient of the tangent. But what do we know? We know that the radius, that one is the gradient of the radius, please. And we know that the radius is perpendicular to the tangent, but radius is perpendicular to the gradient. And for perpendicular lines, these are lines, we say that the product of the gradients of two perpendicular lines is negative 1. Therefore, m1 times m2 equals to negative 1. Let me say that m1 is the gradient of the radius. Let me call it m1. On substituting there, we shall have 9 out of 4, which is m1 times m2 equals to negative 1. When we make m2 the subject of the formula, we shall find that m2 is negative 4 out of 9. Is negative 4 out of 9. This is now the gradient of the tangent. Now, if we know the gradient of the tangent and we know one point on the tangent, we can find the equation of the tangent. So, to find the equation of the tangent, we shall use this point. This point C is for both the tangent and the radius. So we shall use point C, which is given as 1 and negative 1, and then we have the gradient of the tangent as negative 4 out of 9. We know that the tangent is a line, so we shall have y equals mx plus c. We call this x, we call this y. Substitute to get c. So that we have negative 1 equals to m. Negative 4 out of 9 x plus c. Now we can get c. What is c? C is the y-intercept. That is a point on the y-axis when the tangent meets the y-axis itself. So what do we do here? Let us substitute for x here, please. X is 1. X is 1. So that we have negative 1 plus 4 divided by 9. So I'm getting C as negative 5 out of 9. So after getting C, we now say therefore the equation becomes y equals to what is the gradient? N is negative 4 out of 9 x plus it becomes minus 5 out of 9. This is now the equation of the tangent that we are looking for. Please compare this answer to the answer we got using the method of getting the gradient function. This is the answer, which is the gradient of the tangent.